Hi everyone. Today we will going to discuss the magnetic susceptibility and the experimental derivation to calculate the magnetic susceptibility from the Gouy method. This thing we will going to discuss in this class. Let us start the class. Right. Magnetic susceptibility. Defining the magnetic susceptibility. To define this, generally we have to know the relation between the uh, induced magnetic field in a magnetic substance and external magnetic field, right? When we consider that a sample in a external magnetic field, keeping in an external magnetic field, it will be generates induced magnetic field. The magnetic substance will generate in innerly some magnetic field that can be called as induced magnetic field. And we are keeping the sample in an external magnetic field, it has certain magnetism, right? Magnetic field, right? That we will consider that as an H, external magnetic field, right? Relation between these two is B is equal to H plus 4 pi I, right? Here I is intensity of magnetic field, intensity of magnetic field. So this, from this equation number 1, right? B is equal to induced magnetic field is equal to external magnetic field, in addition to that 4 pi into intensity of magnetization, right? Where here uh, dividing equation number 1 both side with H is equal to B by H is equal to H by H plus 4 pi I by H, right? Dividing both sides of equation number 1 by H, right? External magnetic field, where B by H will remain same, that equal to H by H get cancels and it results of 1, number 1, plus 4 pi into I by H, right? Here these particular ratios, right? Ratio of induced magnetic field by external magnetic field will define certain character of magnetization, and intensity of magnetization by external magnetic field will be gives you certain character definition, right? The permeability, is defined as the ratio of induced magnetic field and external magnetic field. External magnetic field, right? This permeability, we has the term of permeability in the last class, where in defining the diamagnetic magnetic substances, paramagnetic substances characters, we said that the diamagnetic substances will have uh, permeability of less than 1 value, and paramagnetic substances will have permeability more than 1 value, right? So there, what is the permeability? Now we are discussing, right? Now we are defining it. The permeability is that the ratio of induced magnetic field in a substance, magnetic substance, by its by external magnetic field, right? That is a permeability. Now the susceptibility. Susceptibility can be defined as the ratio of intensity of magnetization and external magnetic field. External magnetic field. Susceptibility can be defined as intensity of magnetization divided by external magnetic field will be known as magnetic susceptibility. This is also called as volume susceptibility. And given a symbolic presentation of Gouy, right? Permeability is equal to B by H. Volume susceptibility is equal to I by H. The volume susceptibility, this particular susceptibility has different types, right? Volume susceptibility, gram susceptibility, and molar susceptibility, where in defining the gram susceptibility and volume susceptibility is simple of I by H. Gram susceptibility, molar susceptibility can be defined from the volume susceptibility. The gram susceptibility Gouy is equal to ratio of volume susceptibility divided by density. Right. That's how the gram susceptibility will come. Gram susceptibility. Coming to molar susceptibility. Chi-m can be equal to gram susceptibility in multiple of molar weight. Molar weight. Molar weight of the sample. Like this, we have susceptibility definition and it different types, right? Gram susceptibility and volume susceptibility and molar susceptibility, right? Have you understood this? Susceptibility is nothing but the ratio of the intensity of the magnetization of sample divided by external magnetic field, right? Now this particular susceptibility can be experimentally calculated with the help of Gouy's method. right? There is an simple experimental method is there in calculation of magnetic susceptibility of sample, or magnetic susceptibility of sample and magnetic moment. Both can be calculated with respect of Guy's method, by the Guy's method, right? This is a common and simple method to calculate susceptibility and magnetic moment, right? Here what we will have is there is some experimental equipment will be there, right, where it has a external magnetic field. There will be two poles of external magnetic field, and there is a sample glass tube hanging from a base of balance balance of one side. The hanging is in manner that hanging will take place in the manner that the tip of the glass tube, sample gas tube, will be hangs in between the poles, exactly in between the poles. The glass tube, sample glass tube will be hangs in one side of the balance. The other side of the balance, it has a pan to add the weights. It has a pan to weigh, add the weights or subtract the weights. And middle of this base of the balance, there will be scale which indicates the weights. Like this it will have, right? This this particular operator can be compared with a simple vegetable weighing two pan balance, right? In a now and modern days it may not be looking, but in the vegetable market, but in the older days, right, there will be two pan balance in vegetable markets, right? There will be two pans hanging on in one balance, right? Like this it may, in the older days the vegetable markets will have these type of two pan balance to weigh the vegetable, right? Similar to this there will be Gouy operator will be there, right? Here one side pan will be there to add the weights and to separate the weights as such this, and the other side there will be sample, right? Sample glass tube, right, which is hanging in between the pole of external magnetic field, right? That's how. And at the middle there will be scale to give you certain weight of the sample, right? Or it shows that balance, right? Balance of the this weighing balance, right? That is how the operator. With this, what we will do is, right, initially we will going to weigh the empty tube, right? Empty tube weight we will take, empty glass tube weight we will be take, without field, with field, right? Two times we will be measure, right? Without field, this without field, without magnetic field, we'll measure the empty glass tube weight, and with empty, with magnetic field, with magnetic field, empty glass tube we will weigh as a H, right? There we will take the, in next what we will do is, we will take that sample, certain amount of sample we will take, and we will fill into the glass tube, right? Cleaned glass tube we will take. In that will be filled certain amount of sample, magnetic substance we will be add into the glass tube, where again we will go with two times of measurement with without magnetic field, sample glass tube weight without, right? And with magnetic field, sample glass tube weight we will measure, right? After all these, right, after these measurements, to get the sample weight with field and without field, two times we will going to get the sample weight, right? Without magnetic field, sample weight, only sample weight will be get what, right, from W minus WO, right? With magnetic field, with magnetic field, sample weight will be, sorry, this is with right, WH minus WOH, right? There we will get this, right? There certainly there will be some differences, right, will takes place with magnetic field weight to without magnetic field, right? Why it has to take place the different weights, why has to have the different weights without field and to with field, right? When we apply the magnetic field, certain weight change in the sample it takes place, right? Why it has to take place? Because if you consider that this particular sample what you fill, if it is the diamagnetic substance, right, diamagnetic sample if you are taken, right, what happens, this particular diamagnetic substance, right, when it is have magnetic field, right, if you are not applied without magnetic field, if you record some weight, if it is giving an 1 gram of weight, certainly you think that it is have 1 gram of weight, right? Giving an 1 gram weight, it has then zero labeling, so you consider that it weight is 1. then in second time, if you apply certain weight, certain magnetic field, if you apply, right, then in the magnetic field, what happens when we apply the magnetic field here in between the external magnetic poles, right, there the magnetic waves has to flow from one end to other end. To flow here, right, the diamagnetic substance will restrict the flow. This is known to you, right, as its magnetic momentum of diamagnetic substance is zero. It never allow the magnetic waves to flow from it, right. With innerly, it is not allow the magnetic waves to flow from the diamagnetic substance. So far what happens, these magnetic waves will pull the substance from the in between of pole, right. It will force to get out of the glass tube, right. It will be pulled above, right. The external magnetic field will force the substance to pull away, pull upward, right. When it is going upward, right, what happens, the weight of the this particular needle, right, will come imbalanced, right, which nothing but the weight of the substance here will be goes drop, right. When it is going up, if we want to settle it as in zero state, what happens, we have to remove certain weights, right, isn't it. When it is going upward, nothing but what, its weight is decreased or not in the magnetic field, yes, it is decreased, right. When it is decreased, we have to, how much it is decreased, we have to measure. To measure here, we have to remove certain amount of weight, we have to remove. Thus consider that, for example, it is coming as an 0.8 grams, right, which nothing but 0.2 grams of weight is lost by the diamagnetic substance, right. Actually the weight never be lost. Due to this certain force of external magnetic field, it become, the compound will become lighter, right. It is simple that this can be what we can go is, with you consider that the weight loss here, it is not actually by the sample, but it assumes like that the weight of the loss is lost like this, right. The this particular weight loss, right, assumption of weight loss, how we can compare is, you consider that you are in an what we can say, uh, mm, in an escalator, not in escalator, in a lift, right. If you are gone through an apartment, right, and this apartment to get go upward, right, go for the fifth floor, right, fifth floor apartment. If you are, if you want to go for the flat of fifth floor in an apartment, you certainly choose the lift to go till thus, right. When you go there, that, right, when you enter into the lift and when you start the lift, what happens, it is moves upward. When it is move upward, right, certainly you feel some weight increase in the weight, right. Your body feels that increase in the weight, right. It is happens, you just observe it, right. Certainly after the work done in the fifth floor of flat, you will go reach to the till ground, right, ground phase. Again you will enter into the lift and you will come by the lift till ground floor, right. In this coming from lift, coming with lift from fifth floor to ground floor, certainly your body feels that the some amount of weight loss, right. You will feel some lighter, right. The body will become light. The weight of your body certainly feels some weight is lost, right. This actually is your weight is lost, no, it is just is an feeling, right. Because that there is an gravitational force, right. Due to the change in gravitational force, while you are going upward, there is certain gravitational force will works. So with that force you will be feels more weight, right. Where when you come down, right, the gravitational force on you will be gets down. So far your weight assumed as an lost, right. You feels that the weight is lost and you will become lighter, your body will become lighter, similar to that. Similar to that here also, right? When external magnetic field applied while we having an diamagnetic substance in the glass tube, right, it feels, right, the force of the external magnetic field makes that the compound to repelled, and thus repulsion will makes the compound to go upward. With this force of going upward, the diamagnetic substance going upward will make that the balance to imbalance, and it gives you the lesser weight of the sample, right? We have to remove to exactly measure the weight of the sample, right? There you have to remove, right? Certainly that's what happened with an diamagnetic substance. Now you can why we have to go with diamagnetic. Let us take the paramagnetic substance, right? When we take the sample of paramagnetic substance, right, what happens? These paramagnetic substance certainly have some amount of magnetic moment. It never be zero. So far as it is having magnetic moment, right, paramagnetic substance, the waves of external magnetic field will allows from the paramagnetic substance, so it attract by the external magnetic field. While it is attracted by the external magnetic field, the substance will get forced towards the inner side of the magnetic field, right, attracted by magnetic field, so it become weight, right, it will become having more weight by for the paramagnetic substance, right, as it is attracted by the external magnetic field. The weight of the substance whatever it may be, even in this paramagnetic substance, if you consider that 1 gram, right, without magnetic field, in with magnetic field, what happens is that the force of the external magnetic field will pull inner side of the external magnetic field, that creates that the substance will become slightly weighed, right, the 1 gram will become lighter, so you have to add some weight. Thus weight, when you add, it showing that the sample is become some extra weight, right, it carries, it added some weight, right, due to the force of the external magnetic field. When there is a paramagnetic field, the weight will gain. When it is diamagnetic substance, it will be loses some certain weight, right, with the due to the force of the external magnetic field. External magnetic field will make that, right. So that we are calculating by taking empty glass weight with field and without field, and same that in the case of sample glass tube weight with field and without field, there we have to calculate the sample weight, simple sample weight with field and without field, where we will be observe some change in the weight of the sample. That measuring the sample weight with field and without field will gives you the change in sample weight, that is W sample without field, W sample with field, W sample minus W sample H plus or minus, right. That is what happens, right. With this uh, uh, change in sample weight, you will be going to calculate the uh, magnetic susceptibility, and from the magnetic susceptibility we will going to calculate the magnetic moment of the sample, right. So this is what actually we will do, and experimentally there how you are going to get the magnetic susceptibility and magnetic moment. Let us do some derivation, right. There you will come to have uh, the magnetic susceptibility equation, right. There from the magnetic susceptibility equation you will be going to have the magnetic moment calculations, right. This is what experimentally on the field we will do, right. Weighing of sample, weighing of empty tube, right, and that is what we do, right. Actually what happens inner deeply, the concept what happens in the Gouy method is what happening here. Even it is paramagnetic or diamagnetic substance, the magnetic substance magnetic sample when we take, certainly the external magnetic field having some force, right, to attract or repel, right, it is forcing the sample, right, to attract or repel. The external magnetic field applying some force to attract or repel the sample, right? That force you consider that F. F is an total force applied by external magnetic field on sample, right? That to calculate the total force that we have to calculate, right? To calculate that force, initially you go with an small force applied on small volume of sample, right? If we consider a small amount of force is applying on small volume of sample, that could be equal of, right, the small force can be equal of external magnet multiple product of external magnetic field, right, applied external magnetic field and sample volume susceptibility and small volume in multiple of difference in magnetic field with respect of difference in height of the sample what you fill in the sample tube, right? This will be generates, this will gives you the small force which applied by the external magnetic field on sample could be a multiple product of, right, external magnetic field and sample susceptibility and volume of sample on which it is applied the small force and the change in magnetic field, external magnetic field and with respect of change in height of the sample, right? Is it? This could be same, this could be gettable or not, right? The force is depends upon the external magnetic field. When you apply high field, right, it have high force, right, maximum force, right? If you are applying small amount of magnetic field, what happens, the force will be lesser force will be generated, right? So the force whatever we apply on whatever the magnetic field applies, right, will proportional to the external magnetic field and will also proportional to the susceptibility of substance, because how effectively the substance is reacting, nothing but it depends upon the susceptibility, right? If the susceptibility is maximum for a substance, what happens, it the attraction or repulsion of the sample will be maximum, right? If the susceptibility is low of the substance, right, its attraction repulsion by the external magnetic field will also be in minimum only, right? And volume, how much volume is applied, the force also is important, right? If you are applying in maximum volume, the force should be in maximum, right? If you are applying in a small volume, the force will be automatically smaller, right? And there will be change in magnetic field we will do, right? Initially as we discussed, we have uh, regarding the weight of the sample with field and without field, nothing but we are changing the magnetic field, right? And we can also can change the magnetic field amount, right? Some amount smaller, minimum amount magnetic field we can apply, maximum, moderate, like that we can change magnetic field. And we can also change the height of the sample, right? Amount of the sample, height of the sample also we can change, right? So that all, right, when we change these are also the force will also be get changes, right? So the force can be multiple product of these changing factor changes of force, right? So the small force of the sample on a small volume can be equal to its external magnetic field in multiple of magnet susceptibility, right, and small volume of the sample and difference in the uh, external magnetic field with respect of difference in the height of the sample, right? That is what here we know that the volume of the sample can be written as, can be equal of cross area in multiple of height of the sample, right? Volume is an is a multiple product of area and height. We can do is that like or not, right? Volume is an actually multiple product of length, height, breadth, right? So and area is nothing but length and breadth, multiple product of length and breadth, right? So we can write that volume can be equal to area into height, right? Like that volume can be written as area into height, right? So small volume, if we consider, that could be area into small height, right? So this second equation you substitute in the first equation, second substitute in equation number 1, right? Then what happens? Delta F is equal to dF is equal to H into chi into A into dx. dv is equal to A into dx, na? So like that. So in multiple of dH by dx, where this dx will get cancelled, which results of dF is equal to H into chi into A into delta H dH, right? This is what we got, right? Next what happens is that this is what the small force, no? Small force on small volume of the substance. Let us calculate the total force of the external magnetic field on total volume of the sample, right? To get that, we have to be integrate both sides of the equation 3. Equation 3 for total force of external magnetic field on sample, on total sample. That integration of df is equal to, right here chi will be constant. Sample of the susceptibility of the substance never be changed, right? And area of the sample also never be changed, but the changing factor is magnetic field. What we are changing here, you consider that with field, without field we consider, right? Nothing but we are changing the magnetic field, right? We are changing the magnetic field. So the factor to change the variable will be magnetic field, right? That's how we have this. So integration of d force is equal to, will be equal to force, total force, and chi into A. This will be integration, you know that, right? X into dx, integration of x into dx is equal to x square by 2. From this equation, here integration of h into dh is equal to h square by 2. H square by 2. Here limits will be initial to final. The magnetic susceptibility variation from initial to final, right? H naught to h, right? Where here this is equation number 4, where the h naught is equal to 0. Initially what we are applying the magnetic force, we are taking considering, we are weighing the sample without magnetic field, nothing but the magnetic field h naught at initial point, it is 0. In next, h is some amount of magnetic field we are applying, right? So therefore f is equal to chi into A into, right, h minus h square minus h 0, right, or another word h naught square divided by 2 can be equal to A into chi into h square minus 0 square by 2, where it will equal to chi into A into h square by 2. Chi into A into h square by 2. It will be have this, right? This is force, right? Now let us, this is chi is here, we consider that volume susceptibility in general, right? This volume susceptibility, you convert into gram susceptibility. This equation number 5, right? Volume susceptibility chi v can be equal, chi v can be equal to gram susceptibility into d, or another word, gram susceptibility chi g equal to volume susceptibility by d, right? This is known to you, right? Just now I given this, right? The three types of susceptibilities: volume susceptibility, gram susceptibility, and molar susceptibility, right? So the gram susceptibility will be equal to ratio of volume susceptibility and density. Here the density d, we know that it is equal to mass of the sample divided by volume, right? M by v, and we know that volume can be equal to area into length, so m into a into l, area into length, right? Like this, the d can be m by al. Yeah, when we substitute equation number 6 in 5, right? F is equal to gram susceptibility into m by a into l into a into h square by 2, right? Actually the force is equal to actual how, equation number 5. Equation number 5 is that F is equal to gram volume susceptibility into a into h square by 2. So gram susceptibility, volume susceptibility a into h square by 2. In place of volume susceptibility, we are substituting the equation number 6, gram susceptibility into m into a by l, right? So where a get cancelled, a comma a get cancelled, right? Numerator denominator a will get cancelled, right? Finally what we will get, the force equal to gram susceptibility into h square by m by 2l, h square gram susceptibility into h square m square, yes sir, h square m by 2l, right? Where we are here to do this all experiment is aimed to calculate the susceptibility, right? So now get the terms into gram susceptibility. The gram susceptibility can be now equal to 2l into 2l into f by h square by m, 2l into, right, 2l into f by h square m, right, by h square m, right? That's it will cover, right? The m is actual weight of the sample, right? What amount of weight you taken to calculate the susceptibility of the sample, you know, right? 1 gram, 2 gram, how much you initially taken, you know that, right? That is what this, right? Or without magnetic field, whatever the amount of weight, sample weight it comes, that is what the actual weight of the sample, right? That is here, right? And h is, you know that external magnetic field, how much amount of external magnetic field you are applying, also known to you. Length of the sample, how much volume of sample you are filling, also known to you. The thing of force, right, it may be not directly known to you, right? The force, the external magnetic field generating and applied onto the sample is not directly known to you, isn't it? The force, what amount of force it is applied by the external magnetic field on sample is not directly known to you, right? But you can indirectly know that, right? How you can indirectly know that is with the force of the external magnetic field only, the sample either it is repelled or attract, or either it is gaining its weight or losing its weight, right? If it is the diamagnetic substance, it is losing the amount of weight, certain amount of weight it is losing, and if it is the paramagnetic substance, it is gaining the weight, right? It is increasing its weight, right? whatever the amount, if you are whatever the amount of force it is generated by the external magnetic field only, that effectively the weight gain or loss of the sample is taking place, right? If the force generated by external magnetic field is maximum, then what happens? The change in weight will also be maximum, isn't it? If the force applied by the external magnetic field is low, lesser, then the change in weight of the sample will also be very very lesser, in minimum only, right? So here the force whatever it is generated by the external magnetic field can be simply equal to the amount of change in weight of the sample, right? Whatever the sample weight change we are getting, that could be equal to the force of the external magnetic field applied onto the sample, right? That's why we are calculating all this, right? Empty glass weight, in field, without field, with field, and sample glass tube weight with field and without field. Finally, with this all we are getting the change in sample weight, right? Change in sample weight, right? This change in sample weight is actually reflecting the force applied by the external magnetic field, isn't it? So this now we will going to calculate, consider in calculation of force or calculation of susceptibility, right? In the place of force we will apply the change in sample weight, right? The magnetic susceptibility now equal to, gram susceptibility is now equal to 2 into L, length of the substance what we fill, and H is magnetic susceptibility, magnetic field what we have externally, and change in sample weight, right? The force we are considering as change in sample weight, how much differences it is getting with field and without field, that is what sample weight change, that will come here. And mass of the substance or mass of the sample, right? It is an actual weight of the sample, or without field what we are getting the sample weight, that will be here, right? So with this all, right, sample weight, change in sample weight, this is without field, right? Without field, the actual weight of the sample will be without field of sample weight, right? Ws, right? This is what gram susceptibility. To convert gram susceptibility into volume susceptibility, that is equal to molar susceptibility, that is equal to molar susceptibility into gram susceptibility into m, molecular weight, right? Then the molar susceptibility is equal to 2L by h square into change in sample weight by actual weight of the sample into molecular weight of the sample. That all gets the molecular weight, right? Molecular susceptibility of the sample. This is how we will going to have the uh, susceptibility of the sample, right? By all this calculation, right, getting change in sample weight, that change in sample weight here we will drop, here we will write, and there you will get the value of molar susceptibility or gram susceptibility with respect of their equation. When we substitute, we will get, right? Actually this molar susceptibility has some corrections due to impurities in the sample, right? Impurities of sample, if they are having paramagnetic paramagnetic impurities, paramagnetic impurities and diamagnetic impurities, will change the value of molar susceptibility. So the molar susceptibility corrected can be equal to molar susceptibility in manual minus paramagnetic susceptibility impurities susceptibility and diamagnetic impurities susceptibilities, right? Susceptibility of impurities of diamagnetic substances, and we have to separate this, and the susceptibility of paramagnetic impurities also we have to separate from the molar susceptibility, where we will get the exact accurate or corrected molar susceptibility of the substance, right? Molar susceptibility substance, right? This molar susceptibility can be interrelated or has the relation with the magnetic moment, right? There we have an equation, right? Molar susceptibility can be equal to n mu square by 3 kT. The relation between molar susceptibility and magnetic moment. Yes, this equation number we can write that 8, right? Here the capital N, here the capital N is Avogadro number, mu is uh, magnetic moment, K is Boltzmann constant, T is temperature, right? The constant values you know, right? The Avogadro constant value 6.023 into 10 to the power of 23 per mole, and the Boltzmann constant value is 1.38 into 10 to the power of minus 23 joule per Kelvin, or 1.38 into 10 to the power of minus 16 erg per Kelvin, right? And temperature, T is temperature, right? When we substitute these constant values in the uh, last equation number 8, the molar susceptibility, corrected molar susceptibility is equal to 0.125 mu square by T, mu square by T it comes, right? So here, to calculate magnetic moment, mu is equal to under root of chi into T 2.83 under root of chi m corrected into T. So like this we are going to have the magnetic moment value also from the Gouy's method, right? So one more time I am brushing the topic, Gouy's method, which is very much important. So there is a certain Gouy's method which is similar with an having operator similar to the vegetable two pan balance, simple vegetable two pan balance, right? Here also there is one pan at the right side to add the weight or to subtract the weights, right? And the other side there is an hanging tube, right? Base hanging sample tube will be there. It hangs in between of external magnetic poles, right? Where we will be add sample and we measure the weight of the sample, right? The measuring of the weight of the sample with field, without field, we will take place. Initially we will weigh the empty glass tube weight without field and with field, and we will record that. And similar with field, without field, we will weigh the sample glass tube weight, and thereafter we will calculate the simple sample weight by subtracting the sample glass weight from the sample glass weight, by subtracting the empty glass weight from the sample glass weight. We are going to have the sample weight with field, without field, and there certain change in sample weight with field, without field will be recorded, right? Will be calculated. Why this has to happen? Change in my sample weight because of external magnetic field force, right, the substance either attracted or repelled, right. When it is attracted, the weight of the sample will be enhances, right. When it is attracted, the right side pan will be go upward, nothing but it become lighter. So you have to add the weight. When you add the weight, nothing but the weight of the sample is increasing, right. When sample is repelled by the external magnetic field, the sample tube will go upward and the right side pan weights will be become heavier. So you have to separate some of the weight, which nothing but the sample is losing its weight, right. So either diamagnetic substance or paramagnetic substance, the change of weight will be takes place, right, due to the force of the external magnetic field. This is what we practically do on the uh, uh, operator, right, at the operator. But by this weight calculation, how we will going to have the susceptibilities, you have to derive some equation to interrelate the weight of the substances, change in weight of the substance with susceptibility, right, character of susceptibility of sample, right. So to get that, you have to consider the force applied by the external magnetic field on substance, right. This F, we are considering that total force of the uh, external magnetic field applied onto the substance. And there, to calculate total force, initially we are going with an small force. The small force can be equal to its proportional characters multiple product, right. The force can be proportional to the external magnetic field, how effectively you are applying, how much amount of external magnetic field you apply, that respective force it generate by the external magnetic field. So it is it multiple, right. Susceptibility of sample, whenever the susceptibility of sample is high for the sample, it attracted or repelled in a maximum level, right. If it is the susceptibility is low, it attraction repulsions with respect with towards the external magnetic field also be minimum, right. So it is also in multiple, right. The amount of volume of sample also will be in multiple, right. If there are more amount of volume, the the attractions repulsions will be, the force will be maximum. If the amount is less, the attraction repulsions will also be minimum. And there we are recording the change in magnetic moment, sorry, magnetic field, and we can also change the height of the sample. So the small force can be equal to multiple product of external magnetic field, magnetic susceptibility, volume of small volume of sample, and change in magnetic field divided with change in height, right. This will give you equation number 1, from which we will going to calculate the, we will going to have the deriving the magnetic susceptibility equation. So here we know that volume can be equal to length, breadth and height, multiple product of length, breadth and height, and thus length and breadth can be a multiple of length and breadth will be area, right. So you can write that where volume can be equal to area into height, right. So v is equal to a into x, delta v is equal to a into dx, right. This particular second equation, when we substitute in equation number 1, it results of equation number 3, where df is equal to h into chi into a into dh, right. Here this is what small amount of force which is applied onto the small volume of the sample. Let us calculate the total force, right. Then we have to integrate both sides of the equation 3. There in integration we will going to have the equation number of 5, there f is equal to chi into a into h square by 2, where the limits of external magnetic field is, initially we are applied without magnetic field, we are recording the sample weight without magnetic field. At next time we are recording weight of the sample in certain amount of magnetic field, right. Nothing but the initial magnetic field will become 0, the second time of magnetic field will be some amount, right. So it will be 0, that when we all when we keep in that, it will be results of equation number 5. There to replace the volume susceptibility in gram susceptibility, we know that volume susceptibility can be equal to multiple product of gram susceptibility in density. So volume susceptibility is equal to gram susceptibility into density, where density we know that mass by volume, and volume we know that as area into length. So altogether the volume susceptibility is equal to gram susceptibility multiple of gram susceptibility into mass by AL, right? That equation number 6, when we substituting in equation number 5, it results of volume susceptibility replacement of this and into A into h square by 2, where AA will, numerator denominator AA will get cancelled, area will get cancelled, then the force is equal to gram susceptibility into h square by h square m into h square m by 2L. There all this experimental derivation is to calculate the gram susceptibility or susceptibility. So here writing the equation in gram susceptibility is equal to 2L, right? Denominator 2L will go for force side, so 2L into force divided by the numerator, here numerator will become denominator for the force side, so it will be h square by m in the denominator, right? Here the force, right, in this all terms, right, mass of the sample is known to you at initial of the experiment, and external magnetic field what we are applying also known to you, the length of the sample what we fill also known to you, but the thing is force is may not be known, right, directly known, right? But when you think exactly, the force what it applied by the external magnetic field will changes the weight of the sample. So far the force can be written as change in the sample weight, right? So there the gram susceptibility become equal to 2L by h square into change in sample weight divided by mass of the sample or actual weight of the sample, right? That is this, and this gram susceptibility when we convert into molar susceptibility equal to gram susceptibility into m, which is molecular weight. So that again we write, this will come, this molar weight, molar susceptibility is actually has to have some corrections, right, due to the impurities of the sample. That corrections when we do, the molar susceptibility corrected is equal to molar susceptibility minus susceptibility of paramagnetic impurities minus susceptibility of diamagnetic impurities, that results of molar susceptibility corrected. This molar susceptibility is corrected can be related to magnetic moment of the substance, that is equal to molar susceptibility is equal to n into mu square by 2 kt, right, 2 small kt, where n is its Avogadro number, which is 6.023 into 10 to the power of 23 per mole, and k, small k is Boltzmann constant, it has the value, and T is temperature, where all the constant when we keep and when we simplify the equation, the molar susceptibility corrected will be equal to 0.125 into mu square by T, where we require to have calculation of mu, right? So the molecular moment, magnetic moment is equal to 2.83 under root of molar susceptibility into temperature. With this all, we have the calculation, we will be get the molar susceptibility of the sample, also we will going to have the magnetic moment of the substance in experimentally by the Gouy method. So this is how the Gouy method to derive the susceptibility and magnetic moment of the sample. So here I stop the class. By next we will going to have next topics such as magnetic moment and calculation of magnetic moment, quenching of magnetic moment, and more, right? Let us complete today's class. Catch you later, right?